Hello and welcome back. We just finished looking at how to delete from a doubly linked list. Now we're going to program it. So in this example, we're going to program all the types of delete in a single method. Now, some of you might be asking, why are we doing that? Why not make simple types of delete, simple methods for deletion, just like we did with simply linked lists? And the answer is just to mix things up, just to show you that you can do it in any way that you can. With programming, you don't have one single method to do everything in. You can delete, you can insert in any way that you like, and we're going to do that in here. So what we're going to start with is, of course, creating the function or the method, sorry, for the delete. Now, with this type of delete, again, just like with insert, we have different types of delete or removal. Sometimes someone might send you a key, so a value, a data, and you look for it in your linked list and you delete the node that has that data. Other times, someone's going to give you a node and you're going to compare this node with other nodes, and when you find it, you're going to delete it. This is a simple example, so we're going to take a key. So someone is going to send you data, we're going to call it key, and we are going to compare that data with all the data that we have in our doubly linked list and delete the node, the first node that we have that has that data. Okay, so we're going to start with delete and of course self and key that we need in order to recognize the node we want to delete. Keep in mind that with this type of deletion, simple deletion, if I have the same key, so if I have 5 nodes, 2 of them have the number 6. 2 of them have the number 6. This is going to delete the first node with the number 6. It's not going to delete the second one. And you can customize this code later to make it delete all instances of a key. So if I say send the number 6 and then there are 2 nodes with that number, it's going to delete both of them. This program deletes the first instance of a key, just the first one. And of course, it's for simplicity's sake, just to make it simple. We're going, of course, to start with current equals self.head. We want to start at the beginning because what we're going to do in here is a traverse. Again, we're going to start at the beginning and go all the way to the end while looking for that key. We are going to have one of some of the cases, we're going to have one of many cases. So the following cases we can face the following cases. One, your list is empty. So someone is searching inside of a list that is already empty. This is a case that we're going to work with. Another case is we are looking for a key that we find on the first node. So it turns out that it is the first node and we need to delete the first one. Someone is looking for a key in the middle, so to delete somewhere in the middle of a linked list, or someone is looking for a key in the back of a linked list, so the last node in the linked list. What we're going to do is, first of all, the most important thing is in here is to check if it's empty. Okay, so some of you might start to say, why are we sometimes checking for an empty linked list and sometimes we're not? In reality, you need to check for that every single time you work with an application. You need to always check if it's empty or not. Underflow and overflow is something that you need to always check, but we are not checking in some cases for simplicity's sake, to make the code simple and to make the example quick. In here, I'm going to check. Now, if I want to check right now if this is an empty list or not, so if self.head, if it is not equal to none, so if it is not empty, okay, I'm going to do something else. This is to make it simple because this else is going to be at the end of your code. So I'm going to start with it right now. I want to show you what's going to happen. So let me do this. Else, I'm going to print your list is empty. So you are deleting from empty list. Okay, so add it in here. Now, all the code that I'm going to write now is going to be here. I wrote this here because when you write those types of codes, this else is going to be at the end of everything that you're going to add. So sometimes it's simpler to add the if and else if it's a simple if and else like this. I'm asking, if it's empty, do this. If it's not, then print. And that is a very simple very simple if statement. And everything else that I'm going to write is going to be in here, in the middle of those two. And let's start. So I said we are going to face one of four, actually it's one of 5 cases. The first case is that it is an empty linked list, and we just checked it, okay? The second case is if it is the first node, if we are deleting the first node in a linked list. We're going to work with this right now. The other 3 cases are deleting from the middle, deleting from the end, and if you send a key that is not in the linked list. So the last example that we had the numbers from 1 to 5, 1, 2, 3, 4, 5. What if I want to delete the number 0? That is going to be the 5th and last case. Again, 5 cases. Always remember this when you delete. 5 cases. 1, you have an empty linked list. We just checked that. This is the checking of an empty linked list. We're going to work with number 2 right now, which is what if the item that you're looking for, the key that you're looking for, is in the first node of a linked list. And we're going to check that now. What we're going to do is if current the data is equal to key. Okay, so look at this. I said current equals head, and then right after that I said if it's not empty, if this head is not empty, then if current data equals the key. So in this case I haven't moved. Current is still looking right at the head, pointing towards it, and that means I'm at the first node at the first location. If this sorry, if this condition is true, that means I'm at the first node and the key that I sent is equal to its data. So what I'm going to do in here is say I want to delete it, so I'm going to say current next previous equals none. And again, if I go back this example, if I want to delete this, which is the first one, I'm going to say this connector next, so head.next must be deleted, and this, which is supposed to be current, give me a second please. So current is pointing here at this location, and what I wanted to do is the following. This next, so current.next must be none, and current.next.previous is also supposed to be none, to delete both. That is exactly what I'm going to do right now with my code. So current.next.previous equals none, current.next.previous equals none. So this right now gone. And I'm going to do the next part, which is current.next current.next is going to be none. But if I right now say current.next equal none and delete this, head is still here, and head right now does not know where the next part is. So before we delete this, we should say head equals head.next or current.next. Back to code. This is exactly what we're going to do. So head is equal to, let's say, current.next. Even if we say head.next, it's the same thing, not a problem. Then we can say current.head equals none, and thus deleting it. So this concludes how to delete the first item or the first node in a linked list. We're going to see on the next lecture how to delete an item or a node in the middle or at the end of a linked list. Thank you so much for listening, and I'm going to see you on the next lecture.